right, this next lesson is on solving a system of equations by substitution. So in the previous lesson, we were using graphs to be able to solve that system of equations. What is that one point, that one ordered pair that works for both equations? But there's an algebraic way of doing this as well. There's actually two different methods. One is called substitution, and then in the next lesson, we're going to talk about elimination. Now I'm going to start out really easy with you. Again, this example number 1 is a system of equations, meaning that there's more than one equation, and if we were to graph this, we would graph both of these equations on one coordinate system. Sometimes you see a system that has a little bracket on the side, and that bracket just means that, hey, these are together creating a system, okay? And so we all know what the word substitution means, okay? So that's really telling us exactly what we need to do. So here, if you look at this equation, okay, like I said, I'm starting out with a really easy one. We know that y is 5. And what our end goal is to find the solution to our system of equations. So I'm already being told that y is 5. So really what I need to do is to figure out what x is here. So what I'm going to do with that 5 is I'm going to substitute it into this equation in place of y. So my bottom equation becomes 2x minus 5 equals 9. So now I have, notice that I started with an equation that has two variables, an x and a y. Now that I've substituted 5 in for the y, I have one equation with one unknown variable. So now I'm just going to solve this two-step equation. I will add 5 to both sides of the equal sign. So those 5's are gone. And we're left with 2x is equal to 14. And when I divide by 2 on both sides, I get that x is equal to 7. So if I come back up to my final answer up here, I realize that the ordered pair is actually 7, 5. Now, what a lot of students forget to do is they forget to go back and write what that ordered pair is. Okay, so here we're given the y coordinate. Here we just solved for the x coordinate. Don't forget to go back and put those together in one ordered pair. All right, in this next example, again, directions are all the same on all of these examples. We're just trying to find the solution to this system, which means we're trying to find what the x coordinate and the y coordinate is that represents the point of intersection. And so here, notice this one's a little bit different in that we are actually given that x value. So we know x is 2. So if we have our ordered pair here, we know x is 2. What we don't know is what y is this time. So we're going to take our x and we're going to take our top equation. We're going to substitute that x in. So 2 is going in for x plus y is equal to 4. So 2 times 2 is 4 plus y equals 4. Well, this is easy. 4 plus what equals 4? We know that's going to have to be 0. We can demonstrate that by subtracting 4 on both sides, and we get that y is equal to 0. So I'm going to come back in here. I got my x value, I got my y value, and so my final answer will be the ordered pair 2, 0. Our third example is going to be, again, just a little bit different. Examples 1 and 2, I started out really easy because I gave you one of the ordered pairs. Notice here that we don't know what x is or what y is, but we're instead just given two linear equations. So this would be like y equals 3x plus 0, and then the other equation is not even solved for y. So again, in order to solve this, we're still going to use substitution. And since this top equation here is already solved for y, and we know that y is equal to 3x, what I need to do is I need to get this bottom equation, or the other equation, it doesn't have to be the bottom one, I have to get the other equation all in terms of one variable. So it needs to all be in terms of x, or it needs to all be in terms of y. Well, since we already know that y is equal to 3x, what I'm going to do is I'm going to take this 3x, and I'm going to replace this y with it. Okay, so we've got 3x plus 3. Again, I'm going to replace y with what y is equal to, which is 3x, and then that equals 4. Now I'm down to an equation that only has x in it. So I have that 3x plus 9x equals 4. 3 plus 9 gives us 12. Okay, and then we're going to go ahead and divide by 12. Now, a lot of students jump in and they go right to 3 is my answer. This doesn't say 12 divided by 4. This says 4 divided by 12. That's a fraction that can be reduced. Okay, so 4/12 or 1/3. So our x value is 1/3. Now, notice we had to go through all that in order to get the x value, but what about the y value? Okay, well, we know that y is equal to 3 times x. So y is equal to 3x. Now that we know x is 1/3, what we could do is replace x with 1/3 to then figure out what our y is. So 3 times 1/3 equals 1. And so there are our two answers. We've got x, which is 1/3, and we have y that is equal to 1. All right, for our fourth example, again, I'm changing things up and making it just slightly different. Here, notice that there isn't one equation that's solved for x or solved for y. Okay, and so when you're solving these, we're going to have to choose either the top equation or the bottom equation, and we're going to have to solve for one of the variables. It doesn't matter if we use the top or the bottom equation, and it really doesn't matter if we use x or y. However, the recommendation that I would give you is that it's easier to solve for a variable that has a coefficient of 1. So by coefficient, I'm talking about the number before the variable. So since this x in the top equation has a coefficient of 1, I'm going to try to solve that equation for x. So I have x plus 2y equals 0. Okay, so I'm just recopying this equation over here. And in order for me to get x by itself on one side, I need to get rid of the 2y. So I'm just going to subtract that from both sides, and I know that x is equal to a negative 2y. I will then take what x equals, which is negative 2y, and I will substitute that in to the other equation. That's the key in this, in that what you solve, whatever equation you use to solve for, so I use the top equation to solve for x, I then have to substitute into the bottom equation. So that's the really important part. So I'm going to rewrite my bottom equation, only instead of writing x, I'm going to write my negative 2y plus 4y equals 4. So 3 times negative 2 is a negative 6y plus 4y equals 4. And a negative 6 plus 4 is a negative 2y. And when I divide by negative 2, I get that y is equal to negative 2. 4 divided by negative 2 is negative 2. So when I come up here, I know that my answer, I know that my y value is going to be negative 2. Now, how do you find the x? Well, we just got this equation right here saying that x is equal to negative 2y. So how about if, now that we know that y is negative 2, how about if we just replace y with negative 2? So in this case, x would be negative 2 times negative 2, which is positive 4. All right, for our final example, this one is going to end up having a unique answer, so that's why I chose it. And as you can see, I'm looking, since none of these equations are solved specifically for x or specifically for y, I'm looking for the coefficient of 1, and it just so happens that this equation is very similar to the one previously where the first variable with a coefficient of 1 ends up being x. So I'm going to solve this equation for x. So I have x minus 4y is 1. And I'm going to get rid of this 4y by doing the inverse operation. I'm going to add 4y to both sides. Now notice that the 1 and the 4y are not like terms. So I'm going to not combine them. And I'm going to leave x as 4y plus 1. Since I used the top equation to go through and solve for x, I'm going to then substitute it into the bottom equation. So I'm going to take this 4y plus 1 and put it into the bottom equation. So I have 2, x is 4y plus 1 minus 8y equals 2. So I'm now going to distribute the 2. So 2 times 4y plus 2 times 1 minus 8y equals 2. So we have 8y plus 2 minus 8y equals 2. Now notice that when I put the 8y's together, one's positive, one's negative, that's going to drop out and become 0, and I'm going to be left with 2 equals 2. Well, that doesn't help me at all. I'm not able to figure out x, and I'm not able to figure out y, but remember, in chapter 5 when we worked through equations, when you get a number equaling that same number, then that's showing you that it's going to be infinite solution. All right, your homework is going to be a Google form. I promise you are not going to have to do these problems on your own. I realize that you don't necessarily have as much support at home as you would here at school. So you are still going to fill out a Google form, but I'm going to be asking you about details specifically from this video. So again, you won't be able to pass the Google form without watching this video. Have a great day.